talk all about the challenges with that particular program. Whoops. Oh, it's being recorded. Um, Thank you for clicking through that warning light. I suppose it's better than this machine is getting a software update. Uh, and then we have the question of, well, how do I talk about not the vulnerabilities, but my actual products? And of course, that's security advisories. And what we're going to talk about today is how to link them. Now, the important thing to note is we're starting an accelerated race where we're going to know more about potential vulnerabilities because of SBOM. So we're going to have a lot more data, and that data is going to be useful, but it's not all going to be actionable, right? We're going to say, hey, I have at least this many vulnerabilities in my system, but how many of them actually affect me? Because the important thing to note is that not all vulnerabilities actually put you, your organization, your customers at risk. And that's sort of the core takeaway of the problem that we're trying to solve is how do we actually determine this? So we need a way to communicate whether or not a given system, a given piece of software is affected. So for example, the older vulnerability now, a couple of years ago, the Amnesia 33, buried deep in a TCP stack, it turns out you can do all sorts of magical things through this set of vulnerabilities that were discovered by a research team affiliated. It was an Israeli startup that was working with Forescout. So lots of IoT devices were affected, but more importantly, a whole bunch weren't. And so we had this idea that, so organizations, so for example, Zephyr, which is a open source RTOS, said, hey, we needed to sort of communicate to our customers, we're not affected, and our users were not affected. Now, the problem is that doesn't scale, right? We can't go to each of these websites and say, let me check. So you've got thousands of devices in your facilities, you've got hundreds of types of software in your network. How do we actually make this scale? So to do this, we've introduced probably one of the worst named projects in all of InfoSec, the Vulnerability Exploitability Exchange, or VEX. That's entirely my fault. This was a temporary placeholder name, and you guys are probably familiar with the old joke. There's very little in the world that is as permanent as a temporary government program. So we sort of introduced this idea, sort of the thing that we're going to call VEX for now, and then of course it was what we called VEX. So I'm sorry. We've heard most of the vexing puns, but if you come up with a new one, let me know. So first, we need to tackle this term exploitable. And again, if you're in software or in security, you know that this is a pretty big hornet's nest. And the trouble with making things hacker-proof is that hackers are pretty darn clever. And so defining something as exploitable is kind of tricky. So we switched to the term affected, because that creates a broader thing. We're now not looking at the software, we're looking at the user's perspective. And we define affected as, do I need to do anything? So you are affected if there's anything you need to do to remediate or even address this vulnerability. So the example I like to use is there's an awful lot of important safety critical systems that are sold with strict instructions saying, do not plug this into the internet, right? This should always sit behind DMZ, a firewall, whatever. But you can plug into the internet, right? And so something is affected if the user still has to go and say, hey, I wasn't an idiot, was I? Right? So that's still an action that has to be taken. Verifying config still does it. So that gets us out of this challenge of vulnerability versus software vulnerability versus config vulnerability. Anything that allows this. Now, there's also some limits to this. So for example, I talked to a medical device manufacturer who said, we have a proprietary port that one of our employees stripped and hand-wired into Cat5. That is not a config error. That is just having a dumbass as a customer. So that would not trip this particular issue. But we want to, essentially the big picture is capturing this idea that anything that the user needs to take counts as affected, and not affected means You don't have to worry, right? We are just asserting that you as the user don't have to do anything. And we'll talk a little about what that's going to look like in a second. So what is a VEX? It's the binding of three types of data. What's the product that we're talking about? What's the vulnerability that we're talking about? And then what's the status? So essentially, right, you need description of the software and then the vulnerability and the status. And the goal here is to make sure that it's machine readable and automatable. So expanding this a little more, I need some metadata, right? What's the details of this file? What's the product ID? I've got some vulnerability information, some vulnerability details, and then the status, and then some information about that status. So all of a sudden, this is starting to look like a pretty traditional security advisory. And we're all familiar with security advisories, right? You've seen one, you've seen two, you've seen three, you've seen a whole bunch of them. And part of the problem is even when we want negative security advisories, they all look a little different, right? They're really hard to manage. And of course, the number of security advisories keeps growing, and it's going to get bigger as people pay more attention to what's in their software. And as PCERTs mature, as we expand the domain of CVE numbering authorities, and here's the quick plug from my colleagues. If you're not a CVE numbering authority and you would like to be a CVE numbering authority, please reach out to me, and we can connect you to the folks that can make you someone who can assign your own CVEs. So how do we automate this, right? This is the bigger question here. If we're talking about security advisories, how do we make sure that they're actually machine readable? Because today, they come in all different forms. And for example, here, 3 different security advisories, all have the same information, but screw being able to sort of machine parse them. They're not even in the same format, right? Each of these vendors ships them, some use HTML, some use PDF, some use text. So if we're trying to, forget machine readability, we're looking for human readability here. And so the vision here is to say, how do we get this through? So trying to combine these, and you can tell because it's all one talk that is where I was going, which is using the Common Security Advisory Framework, CSAF. Those of you who standards know that CSAF came out of ICASI. And it's been standardized through the CSAF TC in OASIS. Thank you, OASIS. JSON, machine readable, built with automation in mind. And if anyone wants to join that particular TC, I strongly encourage you to do that. It's managed very ably. The chair is Omar Santos from Cisco, but really the guy to talk to is our friend Thomas Schmidt, who was on earlier. Tom, we're going to give you more work. Hope you're ready for that. So what's the vision of CSAF? The vision of CSAF is automation, right? We want automated security advisories that make it easier to build this into your systems, to automate evaluation and prioritization, and be able to map it to what you have in your organization. So what does this mean for VEX? VEX becomes a profile in CSAF. So automated security profile, security advisories. What is a VEX? A VEX is a type of security advisory. And in particular, as I said, it enables the negative security advisory. We're not affected. Uses the same infrastructure and systems. And we'll talk about that in a moment. And VEX should be thought of as a complement to SBOM, not a part of SBOM. So one way to think about it is an SBOM turns on the dashboard warning lights. VEX helps you turn them off, right? Hey, I'm worried about this in this piece of software. Aha, here's something that comes onto my system that says I don't have to worry. So who's going to actually do the work to determine whether someone has to worry? Well, the good news is that in theory, product teams should be doing this already, right? And if you have a security team from your supplier that doesn't have the capacity to do this, that should be a worry, right? And by the way, this applies to open source as well as commercial products, right? Someone should be determining whether or not new risks actually affect a piece of software. And so since good teams already do this, we want to make sure that we can sort of have that information move as quickly and efficiently as possible, and also reward them, right? This is something that we want to sort of say, hey, people should do this, and this should be a feature when looking for suppliers. And the data can come straight to the source. So it can come from the product security team. But the nice thing here is anyone can produce a VEX about a piece of software. So if you have a legacy supplier, an industrial control system, and you want to rely on a company that specializes in evaluating industrial control system software for security, and I'm going to point to a couple of folks in the room that are experts in this, they could produce a VEX. And it's up to you to decide whether to trust it. And we'll talk about that in a moment. So folks are starting to implement this today. This has been integrated into the SBOM healthcare proof of concept work that's been going on for the last few years. So medical device manufacturers starting to produce this, but there are also companies today that are producing VEXs based on security evaluations, and then they're shipping them downstream to their customers. And one way to think about this is an attestation. So at S4, which is an industrial control systems conference, we did a tabletop exercise. And at that tabletop exercise, we sort of asked people to role play suppliers of industrial control system software, or a manufacturer, and we also asked them to role play being a customer, an asset owner, in this case, a water and power company. And the suppliers were focused on SBOMs, right? What do we have? What's in our product? What are our upstream suppliers giving us? But the interesting thing is when they were asked to role play the asset owner, power utility, folks acknowledge, you know what? We don't have the ability today to analyze an SBOM. And that's something that we're going to be talking about later this afternoon, is how do we get to that point? But today, that is not an easy and cheap capability. And what the asset owner really cared about was not give me the whole SBOM. What they really cared about at a point of crisis was, should I care? Tell me if I should care, because otherwise I've got a full-time job. And so this is something that I think we're going to see a lot of demand for moving forward, is this idea of just a simple attestation. Please tell me whether I need to worry. Because if I don't need to worry, that makes both of our jobs easier. I don't have to bother your customer support line, and I can go on to doing the rest of my IoT jobs. So we're going to see this. Now, this does involve a certain amount of trust. There are going to be companies that don't have a good PCERT or that have demonstrated incompetence in the past, and people are just going to say, not going to trust them. And there are going to be companies where everyone says, yeah, they spend a lot of money, they spend a lot of time, and so we're going to do this. So this is also something that we think is going to come in public policy. So we already alluded earlier today to Executive Order 14028, which talks about SBOM, which in turn led to the creation of the minimum elements. What is an SBOM? And part of that discussion was to set up the future. It said, hey, today, this is not part of the minimum elements of SBOM, but the US government has sort of put a marker down on the table saying, in the future, we're going to explicitly talk about the value of exploitability in software. And so this is going to come. And in fact, this document explicitly calls out VEX. So I'm going to very briefly run through just a little bit of the CSAF side of things, right? It's a giant pile of JSON. It is, we can map it to human readability, but again, the goal is not to do that. But here you can see, and this is the downside of my small fonts, where essentially we can capture what's the product, what's the vulnerability, and then what's the status. And we can build this in a whole bunch of different ways. BSI in the German government has built a great tool called SecVisogram. It's online right now. You can build this manually. This is something that I and my team are trying to get a developer to help with, because it's at the moment a little clunky, not through any great fault. It's right. This is the challenge of the first pass through this, especially when something's designed without UX expertise. So it is a very good tool. It also validates, in addition to helping you understand it, it validates your CSAF so you can sort of demonstrate conformance as you build it manually. So you can get your feet wet trying to generate them through drop-down menus, and then once you have them, you can sort of adapt them, and you can see the code as you build it. So it's a great tool. It's something that we're going to be working to help. And as I mentioned at the beginning, this is something we're building as we're flying, right? People are already doing this, but there's work that's continued. So we just published a document on SBOM, on VEX use cases. So the vision here is to say, hey, how do we manage this? What does it look like? And we wanted to sort of have, what's the modality is the term that I used until everyone said, that's a terrible term, Alan. Stop calling it modality. Let's call it use cases. So essentially, you could say a VEX could be one product and one vulnerability. Pretty simple security advisory. It could be many products and one vulnerability. This is the Log4j approach. It could be one product and many vulnerabilities. So this could be the third-party security testing announcement. So there are lots of ways this can be done. If you go to cisa.gov/SBOM, there is a document that lays out the different use cases and also provides examples in both CSAF and CycloneDX. I'm talking today about CSAF because that's where the US government would like to go in terms of security advisories. But it's important to acknowledge that CycloneDX has also implemented the VEX model. And then we have the idea of status justifications. So this says, hey, it's not just enough to say that something is not affected. I would like information about why it's not affected. And so we refer to these as status justifications. So what are they? Well, there are 5. You can think of them as progressively harder to validate or harder to prove. So one of them is just saying, hey, component not present. And you'd be surprised how often people want this very simple thing, which is, imagine post Log4j, a whole bunch of people had to communicate to their customers, we're not affected by Log4j because we don't use Java, right? Now, imagine, and my team, some of you know Justin, basically had to spend most of Christmas designing a giant GitHub to manage the list of software that was affected and software that was not affected. And for those of you who are good at set theory, you may realize that that is the sum of all software. So again, how can we do this in a way of scaling would be very useful. Just being able to say, we don't use it, and we don't use it because we don't use that component helpful. So then you can say, well, I do use the component, but I don't have the code that actually is the vulnerability in my product, right? Especially for things like embedded software where the compilers are very violent. We don't have that, that code simply isn't in our software. So for example, yes, I'm using OpenSSL, but I'm only using the PRNG. I don't know why I'd use that PRNG, but only using that PRNG. So, right, the heartbeat function simply isn't in my product. So again, that's the sort of thing that you may say, I can build a policy to say, always trust that assertion because it's easy to verify or someone's probably verified it. And then we get to some of the harder pieces. So code cannot be controlled by the adversary. So yes, it's in there, but it's in a chunk that simply the adversary can't touch, or it's not in the execute path, right? So it's the code is called from a function, from a conditional, but that conditional will always go one way. Or another example that we've heard is large vendors often ship software updates with rollback. So a binary analysis tool will find that this outdated version of a library is in the product, but it's not in the product that is actually running. It's in the rollback part of the installer. And then last, we can say inline processes already admit, so it's not a patched, but there's already, so for example, I call a function that is vulnerable to Stack Overflow, but I sanitize that input somewhere else. So we're not worried about it. So those are the status justifications. Duncan already alluded to the idea that you could now start to build policies to say, I'm going to trust these 3 or 4, and this one we're going to sort of escalate to this approach or require a manual process or something like that. So problem solved. Hooray. We're all doing this. Well, some of us are doing this. And more of us are doing it all the time, but we still need some support. And since it's the automation workshop, let's talk a little bit about what it's going to take to automate this. One of the classic challenges, anytime we have information that's coming from distributed sources, is how do we actually manage this? Right? What's the distribution model? What's the retrieval model? How do I map it? Is it push versus pull? Do we want it to be centralized? One of the reasons that our friends in the German government have been pushing the broader concept of CSAF is because they want to help German industry understand what's actually affecting them. And so we can imagine both either a government or indeed anyone in the private sector being able to play a role to say, we will help you understand what's on your network and point you to what's actually important. We also need to focus on integrating VEX with existing tools. We've already had a little bit of conversation about that, thanks to Duncan. And also thinking about how do we integrate this into judgment and policy. So again, saying I'm going to trust it from this sources, I'm going to sort of escalate for these sources. This kind of status justification is okay. And then one of the challenges is sort of, hey, let me make sure this data can correlate with all the other data in my system. CSAF has the ability today to explicitly link to SBOMs through. The question is, are SBOMs easy to link to? That's a separate question. But if you can link to an SBOM through URL, we can do that in CSAF. We can also link to specific components. The challenge here, and for those of you in the room, it's covered by the Zoom window, is of course actually linking to the identity of that component. And this touches on one of the bigger challenges here, which is software identity is a known hard problem, and we're still trying to figure it out. This is something that CISA has been engaging with. We've been talking with our friends at NIST for a while. We know that this is broken. We know that the solutions that have been tried in the past, such as a centralized database like CPE, not really working. And we know that the problem isn't that we don't have any standards, it's that we have too many standards. And we can talk about a path to convergence, but we're going to need some approaches that involve federation and aliases, and probably in the short run, smarts, if you really care about precision, some smart services that help with your deduplication and your alignment. So these are some of the fun automation challenges. Very happy to talk about what other things you guys are interested in thinking about for this topic. But just wrapping up, I'll point out that we need to sort of start thinking about and testing this. There are some folks that are working on this, including some large organizations in the industrial control system space, the healthcare space, and in the open source space. So there are lots of folks moving in this direction, but we need more to validate it, test it, find out what doesn't work. So for summing up here, more vulnerabilities are being discovered. Better insights in the supply chain means that we're going to have more advisories. Those advisories, we need to nudge to an expectation that they should be machine readable, automation friendly, and VEX is going to be a key part of that, aligned with the CSAF model. So there's some links for you, cisa.gov/SBOM, and there's the GitHub for CSAF if folks want to get involved in that OASIS project. There's my information. And hopefully, since I'm the guy who's standing between you and your lunch, we won't belabor this conversation too much, but hopefully I've given you something slightly new to think about. So thanks for your time.